All right, doing it again. Much smaller exponent this time, so that's nice. Because we're raising this thing to the fourth power, we're going to have 5 terms. Sure, that'll be fun. Pascal's triangle, that's one too many pluses. Pascal's triangle can get us the coefficients. Remember, Pascal's triangle starts and ends with a 1. And then to get the rest of those, you can go ahead and just Google Pascal's triangle or look back on your notes because the 4th row is in our notes. And we will want this one right here. 1, 4, 6, 4, 1. All right. So notice that this one now has a coefficient for the first term. We've got a 3 with that m. So we'll be taking 3m, the whole term, to the 4th power, and that will decrease by 1. 3m cubed, 3m squared, 3m to the first, and then 3m to the 0. After that, we've got a negative 1. Woo, get out of here. We got that negative 1. So there'll be a negative 1 to the 0, negative 1 to the first, squared, cubed, and to the 4th. All right. Important to go at some point, just kind of double check your exponents. Hey, 1 plus 3 does equal 4, so we got that one. Same thing here, 3 plus 1 is 4, so that's good. 2 plus 2 is 4, so we're good there. Our exponents do all add up to that 4 we started with. So a bit of simplifying can take place here. Note that this 3 is being raised to that power 4 as well. It's not just the m. So we can do a bit of simplifying, clean this up a bit. We've got a 3 to the 4th power here, so there will be an 81. And negative 1 to the 0, well, anything to the 0 power is just 1. So we don't have to worry about that. Jumping down along the line, 3 cubed is a 27. And negative 1 to the first power is a negative 1. 3 squared is 9. Over here, negative 1 to the second power. Remember, squaring a negative number will make it positive, so that's now a positive 1. This one will get a 3. Negative 1 cubed is a negative 1. And then that's going to go away. That's just 1. And negative 1 to the 4th is a positive 1. I recommend doing that simplifying ahead of time, just so that you have all your numbers straight. You know what's going to go in your calculator if you need your calculator. So a little bit more going on in this problem in order to get that final polynomial. So we've got our coefficient of 1, an 81, and a 1. Not too crazy. 1 times 81 times 1 is just 81. And then we do want to remember there's an m in there. And that m is raised to the 4th power. So we have 81 m to the 4th power as our first term. Moving down the line, kind of drag all of these at once. Hey, that's fun. Moving down the line, note that now there's a negative 1 in there. So I will have a minus that second term, which is 4 times 27. It's 108. Next term, we have a 6, a 9, and a positive 1. So that will be 6 times 9, which is 54. Coming to the bottom row here, that negative is back. So we have 4 times 3, which is negative 12. When we take that negative 1 into account as well. Forgot an exponent here. And then last but not least, 1 times 1 times 1 is just 1. Woo, boy. So there we have it. Let's take a look at one where both of our terms have a coefficient. Good times. So exponent's still not too big here. We're talking about something to the 5th power. So we are going to get 6 terms. All So we want the 6th row in Pascal's triangle. We want the 5th row in Pascal's triangle, talking is hard, which will be that row right there. So 1, 5, 10, 5, 1. Yeah. All right. And then sticking with our convention from previously, we'll let that first term be green. So that is going to start off at the 5th power and go down by 1 with each term. And then note we do have the negative there for the 2nd term, so that's going to continue flip-flopping signs just like in the previous example. So it starts off to the 0, and then it's going to go up 1 from there. Two, it's now 3. Very nice. All right. So at this point, we have everything written out. We've got all that work. And now we can start doing a bit of simplifying. So we start off by looking at our powers of 4. 4 to the 5th is 1,024. 4 to the 4th is 256. 4 cubed is 64. 4 squared is 16. 4 to the 1st is just 4. And that last one goes away because anything to the 0 power is 1. And then we also have our powers of 3. Keep in mind there is that negative that's going to play a role here. This one is just 1. Negative 3 to the 1st power is a negative 3. Negative 3 squared is a positive 9. Then we go back to negative. That'll be a negative 27, a positive 81, and then negative 243. And again, that one's just 1. So now we have our simplified coefficients. And at this point, if you want to pull out a calculator, you just want to work through this manually, whatever you want to do. Take a look at this very first term. Let's do blue. Blue is fun. We'll be multiplying 1 times 1,024 times 1. Yeah, that's just 1,024. Don't want to lose our variable here. Remember, there is a c in there, c to the 5th power. And moving down the line. For that second term there, we're multiplying those 3 numbers together, which will give us a negative 3,840. And now we do want to be careful because 2 variables showed up in this binomial, so we'll have a c to the 4th and a d to the 1st. After that, we have the 10 times the 64 times the 9. That 9 kind of looks like an A, doesn't it? 9. 10 times the 64 times that 9, which gives us 5,760. And again, 2 variables. We've got the d squared as well as the c cubed. Jumping down to the bottom row. Now we have 10, 16, and negative 27. Which is going to give us negative 4,320. And now our variables are going to be c squared and d cubed. Not even going to try to get all this in one row. Still 2 to go. 5 times 4 times 81. This one will be positive. So 5 times 4 times 81 gives us 1,620. Once again, taking into account those variables, we have a c to the 1st and a d to the 4th. And last but not least, 1 times the negative 243 is just going to be a negative 243, and the variable there is d to the 5th. So because there's two variables here, just like before, we can go back and do that quick double check. Hey, 2 plus 3 is 5. That is our original exponent, so that's solid. That's what we expected. Same thing here, the 2 and the 3. So there are all these double checks that you can do as you're going through the process. But yeah, there we have it. Still better than foiling. Very nice. Briefly mentioning the next two on the notes there. If you want to give them a shot with Pascal's triangle, I'll go ahead and give you the answers. But they are fairly difficult because you have that variable in the denominator. Feel free to play around with this if you want to. That's what the answer would be. In 10.6, the next section, we're actually going to get other ways to play around with the idea of a series. And so we'll mess with that in the next section. We won't use Pascal's triangle for this kind of problem then. But go ahead and try it. It's only to the 3rd power. Could be fun. 6, don't go ahead and try unless you're really bored. Yeah, that's the final answer there. Note that you'll start off with your polynomial having a to the 6th power, and by the end of it, that's in the denominator. That's a fairly challenging problem. Yeah. Again, we're going to start playing around with other ways to get these series ideas out, and we'll do that in the next section.